Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, gentlemen, we are going to start talking about systems of equations. And when we're talking about systems of equations, there are three ways to solve them: by graphing, substitution, or elimination. And today we're going to talk about graphing way of solving systems. And a system of equations is a set of two or more equations. It's that simple. It's used when you have two or more related unknowns. So when you have two unknown variables and you have two or more equations involving two or more unknown variables, you're going to use systems. A linear system, gentlemen, consists of two or more linear equations. Remember, if it's linear, the power of x is 1. Remember the y equals mx plus b form. A solution of a system is a value or a set of values, ordered pairs, x, y, for the variables that make all of the equations true. So when you have a solution for a system, it's going to be that x, y, that ordered pair that's going to be true for both equations. You're going to make both equations true with that value. Okay? Now, that solution is the intersection of both lines. The solution of a system is the point at which both equations are equal. So for example here, gentlemen, the solution of a linear equation, like I said, is the intersection point of the given linear equations. For the equations y equals 1/2 x plus 5 and y equals negative 1/2 x plus 3, the solution is negative 2, 4. How come that works that way? Well, when I graph both of these equations, my intersection point is literally right here. That's where both lines intersect. So the point negative 2, 4 is a solution. And if I plug them in, I can prove that it's a solution. If x is negative 2 times 1/2 is negative 1, plus 5 is 4. It works. If x is negative 2 here, negative 1/2 times negative 2 is positive 2. Positive 2 plus 3 is, whoa, positive 1. Sorry, Moro, learn how to do math. Positive 1. 1 plus 3 is 4. It works. So the beauty of this, if you graph it and you look at your graph and you're like, I don't know about this graph, plug it in, guys, and see if you got the right answer or not. Okay? It's that simple. Next, let's find the solutions by graphing. First thing you always have to do is solve for y. So I'm going to add my 3x to both sides. I have 2y equals 3x plus 8, divide by 2. So I've got y equals 3/2 x plus 4. We'll do that in red. This guy we'll do in blue. Subtract x to both sides and divide by 2. So y equals negative 1/2 x minus 4. Now let's graph them. Y equals 3/2 x plus 4. My y-intercept is 1, 2, 3, 4. My slope is up 1, 2, 3, 2 to the right. Up 1, 2, 3, 2 to the right. Let's go backwards. Down 1, 2, 3, to the left. Down 1, 2, 3, to the left. Go ahead and connect those dots. Make that line. And now let's graph the next equation. Y-intercept is negative 4. 1, 2, 3, 4. My slope is negative 1/2. So down 1 over 2. Let's go backwards. Up 1 over 2. Up 1 over 2. Up 1 over 2. Bingo. We got a perfect intersection right here. My solution is 1, 2, 3, negative 4, negative 2. And if I plug those in, it will solve or satisfy both equations. So if you know how to graph a linear function, you're going to have no problems here. Okay? Does that make sense so far, guys? It's not too bad, right? Not too bad? Good, good. Okay, now, you can classify a system of two linear equations by the number of solutions that you have, guys. Okay? You're going to have either a consistent system or an inconsistent system. If you have a consistent system, that means you have at least one solution. If you have what's called an independent system, if it's independent, that means that the slopes are different and you have one exact solution. Okay? That means that the slopes are different and you have one exact solution. If it's consistent dependent, that means that you have the exact same line. You have the same exact slope, the same exact y-intercept, and what's going to happen is you're going to have the same exact solutions. So it's known as infinitely many solutions because they're the same line. So you see two equations, two linear functions, and they have different slopes. Immediately you know they're going to be independent. There's going to be one solution. If you see that they have the same slope and the same y-intercept, it's the same line, it's a dependent system. That means that they have infinitely many solutions. All numbers will work. And then if it's inconsistent, this is the easy one, guys. If it's inconsistent, that means that the lines are parallel. That means that the slopes are the same, but the y-intercepts are different. And that would be an inconsistent system. So it's consistent, that means there is at least one solution. If it's independent, it's one solution. If it's dependent, it's infinitely many solutions. If it's inconsistent, that means that they're parallel. They have the same slope, and that means that there is no solution. Just to give you an example, if you have intersecting lines, you have one solution, it's consistent, it's independent. If you have coinciding lines, infinitely many solutions, it's consistent and it's dependent. If you have parallel lines, you have the same slope, they never touch, they're no solution, and they're known as inconsistent. And now, real quick, without graphing, I know the bell's going to ring, I will continue, you can go to lunch. But if you so choose to stay, you can stay. If not, enjoy your lunch, I'm going to finish up. Without graphing, is the system independent, dependent, or inconsistent? It's very simple here. All you got to do is solve for y and compare the slopes. So what I'm going to do here is I'm going to solve for y. Do this guy in red. It's going to be y equals 2x plus 6, and then you're going to divide everything by 4. So y equals 1/2 x plus 3/2. Now do this guy in blue. Let's divide that by 8. So I've got y equals 1/2 x minus, let's see, 3/2. So what's going to happen here is you're going to literally, without graphing, I can tell you right now that this is going to be an inconsistent, no solution. Why, Moro? Because the slopes are the same, but they have different y-intercepts. So whenever they tell you to determine if a system is independent, dependent, or consistent or inconsistent, it's very simple. Solve for y, put it to y equals mx plus b form, and then compare the slopes. If the slopes are the same with different y-intercepts, then the lines are parallel, there's no solution. If the slopes and the y-intercept are the same, then the lines are the same, and therefore they have infinitely many solutions. And if the slopes and the y-intercept are different, they're not equal, then the lines are independent, and there is only one solution. Question? And then I'm just going to answer these without graphing. So for this particular case, this is y equals 3x plus 4. And here, this is going to be negative 1/3 y equals negative x plus 1. Multiply everything by negative 3. Y equals 3x minus 3. Wait a second. Same slope. That's it. They're parallel. No solution. It's inconsistent. When they have the same slope and different y-intercepts, that means they're inconsistent. There's no solution. Without graphing, tell me if this system is independent or dependent. Okay. Again, I'm going to solve for y. So I got 3y equals negative 2x plus 1. Divide by 3. y equals negative 2/3 x plus 1/3. And then this guy here we'll do in blue, y equals negative 4x minus 3. The slopes are different. We're golden. That means you have one solution. So that means this is independent. This doesn't solve anything. It just tells you how many solutions you're going to have. Not bad, right? And then last but not least, now find this by graphing. So I'm going to graph it. So I'm going to solve for y here. So this is going to be, oh boy, sorry about that. Let's see if it'll work now. So this will be y equals, this is going to be 1/2 x minus 2. And this is going to be y equals negative 3x plus 5. So I got y equals 1/2 x minus 2. So my y-intercept is negative 2, up 1 over 2, up 1 over 2, up 1 over 2. Backwards, down 1 over 2, down 1 over 2, down 1 over 2. Connect those dots. Now this guy here, let's do this in red. Y-intercept is 5, 1, 2, 3, 4, 5. Down 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1. Bingo. Right there. Bam. That's my solution. 2 comma negative 1. If I plug it in, it works. Thank you for those of you who stayed behind. I really appreciate that. Hope that helped. God bless you. Hope you learned a lot and have a wonderful day. Bye-bye now.